Okay, today's lesson for Algebra 1 is lesson number 88. This is data distribution, so continuing our unit on statistics. This lesson is going to talk about how to categorize data. So we've learned how to represent data with box plots, bar graphs, histograms, and dot plots. And now we're going to learn another way to interpret that data. So we're going to talk about if a data set is symmetric or skewed. The definitions of those words would be here. So symmetric, the distribution is symmetric if the mean basically lines up with the median. So it'll look something like this, right? We think of data as usually having kind of this curve to it where we have most of the things falling into the middle and then some are out on either end. So that's kind of the normal kind of curve, and when we see that we would call it symmetric. Here this is an example of a histogram that we would call right skewed or skewed to the right. We use this term when the mean of the data set is to the right of the median. Okay, so this basically happens when the graph has kind of a tail to one side. So see, if we wanted it to be symmetric, it would look something more like this, right? But instead there's this extra stuff over here. Okay, so it has more values to the right. So we say that that's skewed to the right, or right skewed. Okay, and then here, same kind of thing, right? If it were to be symmetric, it would kind of look like this. But we have a lot of extra stuff going on, right? Our curve actually goes like this. So there's a lot of extras over to the left. So this would be left skewed or skewed to the left. Okay, we could also find it numerically. This happens when the mean is to the left of the median. So it would be less than the median then. Okay. So if you were absent and you're just writing this down, make sure you get the definitions and the sketches here as well. Okay, here's some examples. If we were given the data set, we could find the median and the mean and compare those. So we could do this numerically. We find the median is 3 for number 1. And the mean, if we add these, we get 27, and there are 9 terms. So we would do 27 divided by 9, which is 3. Okay, these are equal, so we're thinking this is going to be symmetric. We can see that with the dot plot as well. If we want to look at it more visually, we can make a dot plot going from 1 to 5 on our number line, and then marking how many times we see each of these numbers. So there's 1 1, 2 2s, 3 3s, 2 4s, and 1 5. Okay, you can see if I were to split this down the middle, it's symmetric on both sides, right? So it has that kind of a mirror property, like symmetry. So we would say that this one is symmetric. And for number 2, we could do the same thing. So we could find the mean and the median and compare them. The median here is 5. If we add the numbers and divide by the number of terms for the mean, we get 46 here, divided by 11 is about 4.18, and we can tell that that's less than 5, right? So the mean here is less than the median. On a number line, that means it would fall to the left, right? So this would be like our mean here and then the median. Okay, so the mean would be less than, right? So it's to the left. On our dot plot, we could see this information visually. We have 1 1, 1 2, 1 3, 2 4s, 4 5s, and 2 6s. So from the dot plot, we can tell as well that this is skewed to the left or left skewed. We could also look at this kind of as, well, this would be like the normal symmetric thing, but instead we have extras over here, right? It has this tail going off to the left, so it's left skewed. Okay, number 3 is kind of a silly case, but we can still look at it. We would want to list the data from least to greatest, and then I can find the mean and median just like I did in the other two. So I have 7.5 for the median, and then the mean, if I add those, I get 30, divided by 4 is also 7.5. So they're equal, so this would be symmetric based on our definition. And if we look at the data, it is symmetric, but it's not a very interesting data set here, but it would technically be symmetric, right? If I put a mirror here, it's the same on both sides. Here for number 4, maybe I'll just look at the dot plot here. So I see these numbers go from 3 to 8. I have 1 3, 2 4s, 2 5s, 1 6, 1 7, and 1 8. So this is skewed to the right. Okay, it would be symmetric if these numbers weren't here, right? If I could just stop after 6, these are kind of a mirror image of each other, so that would be symmetric. But I can't just cut numbers out, right? So this is actually skewed to the right then. There's this extra tail here. And then again back here, number 3, this would be symmetric. Okay, so here's some examples where the graph is already given to us. We have a histogram, some histograms up here, and then a box and whisker plot. For the histograms, we've seen these with the definitions, right? So this first one, you can see this part looks symmetric, but there's really this kind of long tail on the right. So we would say that this is right skewed. Okay, the second one, it may be technically a little bit off, right? We would really want this to be a little bit shorter here, and then this one to maybe be a little bit shorter here. But really the mean and the median of this set are going to be extremely close together, so they would be approximately equal. This has a general smooth curve to it. So this we would say is symmetric or approximately symmetric if you want to be kind of picky about it. So here for the box and whisker plot, we want to look at where the median and the mean fall. So remember, for box and whisker plot, this represents the lowest 25% of the data. So say I surveyed 100 people, and these were the prices of their orders at this cafe. So 25 people fell between $4 and $6, or their order was between $4 and $6. 25 people had an order between $6 and $7. And then 25 people had an order between $7 and $13, and 25 people had an order between $13 and $19. Okay, so my median is back here at 7, but do you see that the range of this, I have values going from 4 all the way up to 19. This one was 7. So if I kind of think of this as a curve, I have a lot of people, so a lot of data entries in here, so I would have kind of higher bars here, and then this kind of slopes down. I have these extra numbers over on this side. Again, median would kind of be the highest point, and then it's going down. So this would be right skewed. Okay, if I think of the average of this set, right, I have numbers going from 4 up to 19. So you can see the numbers up here are probably going to pull the average to the right. Okay, so my mean is going to be somewhere to the right of the median. So this would be right skewed. This says left, but that's not right. It would be right skewed. Okay, sorry. There we go. So this would be right skewed here for the box and whisker plot. Okay, here's some more examples on this slide. So let's start with the histogram here. So this one has, if you can see, kind of a curve going, but there's this long tail, right? These values are going to move the average to the right. So this would be right skewed. Over here for this dot plot, I see this is kind of my curve of the data, right? So there's definitely a long tail over here on the left, so this would be left skewed. Okay, and the dot plot down here looks approximately symmetric, right? Kind of a natural curve there. So this would be symmetric. The box plot up here, if I think, okay, I have the same number of people here as I do here and here and here, right? So the median falls here. This would be the middle number. And then the people on the lower end here, right, over at 11 are going to pull this average down. So there's the same number of people on the lower half as there's on the upper half. So there's more numbers that are going to kind of pull the average of this down. So the average will be to the left of the median, so this would be left skewed. Okay, I could also think if this was my median, I'm thinking I want my curve to kind of be normal like this, but instead of having that, I still have all these numbers over here. So I have extra things on the left, so it's left skewed. I could also think for the box and whisker plot, I could think if this was the median and I had a symmetric box and whisker plot, it would kind of look like this, right? These would have equal little boxes on both sides. The whiskers would be an equal length, right? But instead I have extra numbers that are below, right, on the left side. So again, those numbers kind of shift the average of the data to the left. I could also think of using the same data from this histogram over here. I could also use a box plot to show the same data. So if the min is down here and the max is up here, then I could kind of count in using the frequency. So I know there's 8 here, so I could cancel out from the top. Okay, here's 1, 2, 3, 4, 5, 6, 7, and then 8 kind of from the upper end of numbers. Okay, so I'm just canceling in to try to find the median. So I could cancel out another 2, 4, 6, 8 on the lower end of numbers, another 2, 4, 6, 8 on the higher end of numbers, and just keep going in. Okay, so 2, 3, 1, 2, 3, 4, 5, 2, 1, 2, 1, 2, 1, 2, 1, 2. And then I'm left with some number in this bar here would be in the median. So somewhere between 4 and 6 is my median, so maybe that's here. Okay, and then I could do the same thing with the lower half of the data. Could kind of work my way into the middle here. So if I'm canceling these out, I end up somewhere in this column, so my Q1 would be somewhere here. I could do the same thing for the upper half, so Q3, if I find the middle, I'm somewhere over here for that, for the middle term of the upper half. So this would be kind of what my box plot would look like. Okay, so you can see, remember this one was right skewed because these numbers shift the average to the right. So this box plot would also be right skewed then, right? It's the same data. Alright, so that is it for today's lesson. Go ahead and give the homework problems a try, and I will see you guys tomorrow. Thank you.